Welcome to the CCS Library Material Collection video series. This video will be covering the polymer section of our collection. Out in the world, we are surrounded by polymers in both nature and our built environment. Polymers are applied in various forms throughout the art and design industry, so it can be quite useful to understand them. Being able to utilize the fundamental building blocks of polymers opens us up to a world of new possibilities. The polymer section of our library is organized under subcategories, including pigmented polymers, resins, decorative and structural tiles, polymer processing, performance polymers, rubbers, and foams. The term polymer originates from the Greek, with poly meaning many and mer meaning parts. A polymer is made up of a chain of connected singular monomers and can be human-made or naturally occurring. Some naturally occurring forms of polymers can be found in animal fibers, food, and plants. When it comes to human-made polymers, many people use the terms plastic and polymer interchangeably, but they are different. Polymer is an overarching category describing a chain of connected singular monomers, whereas plastics are a subcategory under the polymer umbrella. Plastics are a type of polymer chain, typically based in oil, and are not found in nature. There are two main categories of plastic polymers: thermosetting and thermoplastic. Thermosetting plastic polymers can be heated and set into a specific shape and cannot be reformed. Thermoplastic plastic polymers can be reheated and reformed multiple times. Now that we understand plastic as a type of polymer rather than a synonym for it, let's take a look at three other significant types of polymer structures. Cross-linked polymers. Cross-linking polymers occur when separate chains of molecules connect to each other. This often happens because a catalyst is introduced and bonds multiple chain molecules together. This results in a stronger and more chemically resistant molecule that is less elastic. Copolymers. These contain more than one type of monomer. Most of them are connected randomly without a set pattern, so the polymer will get some properties of each monomer. By changing the ratios of the monomers, completely different polymers can be made out of the same monomer components. Copolymers are more difficult to recycle due to the difficulty of separating them back down to the component monomers. Functional groups. The backbone of molecules consists of a long chain of carbon atoms linked together. The groups of atoms that hang onto this backbone are the functional groups. These atoms control the properties and functions that make each polymer different from one another. For example, let's take a look at a molecule with a backbone of carbon. If this molecule has hydrogens as its functional group, it becomes polyethylene, a common material found in plastic grocery bags. However, if we swap out the hydrogen with a fluorine functional group, it becomes polytetrafluoroethylene, which can be found in Teflon cooking pans. Comprehending the foundation and different forms of polymers can make a significant difference in a designer or artist's practice. By being able to understand the makeup of the materials used in the world around us, we are better able to build and create the future we all hope to see.